So hello everyone, I am Kaleeswari, an assistant professor from Department of Computer Application at SFR College. Today we are discussing this lecture video, Simply Linked List. What is Simply Linked List and what are the types of linked list are available in that video. So next, whether you are the student or we are interested about the data structure, this video is very helpful for your studies. We start our session. So first of all, we comes under the learning objectives. First, we introduction to the linked list, basic terminology of the linked list, importance of the linked list and types of linked list and operations on simply linked list. Today we discussing these chapters only. Next, first one is an introduction to the linked list. So what is a linked list? So linked list is a linear data structures. So what is linear data structure? So linear means the data are arranged in a sequential manner. So they are arranged in a some format. So sequentially they arrange the data. So next one is a linked list. So how can be defined? So linked list can be defined as a collection of objects are called nodes. So what is a node? So node means nothing but it is a fundamental components that containing the two parts. First one is a data part, next one is a reference that hold the address of the next node. So next one is so it is different from the array concept because the array has some limitations, but linked list has there is no limitation to store the data. So before we move on to the simply linked list, we know that basic concept for basic terminology about the linked list. First one is a node. So already we say that node is a building block of the linked list. So each node which containing the node and other part is a pointer. So node which containing the value, so data or information that can be stored in the data part. Next one is a pointer. So the pointer which containing the address of the next node. So next one is an head, another one is an tail part. The first node always told us an head node and the last node which always told us an tail part. So importance of the linked list. Why we are moving to the linked list? For organizing the group of elements, linked list is the most flexible compared with an array. If you are using an array, you must know the size before using that program. If you are increasing the size in the runtime, it is take more time and also it is elements are stored in the contiguous manner. So some disadvantages present in the array, but linked list is a data structure which can overcome the limitations occurred in the array concept. So we move on to the linked list. So first advantages is a dynamic size, that is they can be grow or shrink as needed. So there is no fixed size. So this is the first advantages. So next one is an efficiency. Actually we also insertion and deletion, it is more efficient. Next one is an complex data structure. They form the basic for stack, queue and other structures also. Next one is a memory efficient. They use the memory only for nodes needed. So memory efficient is one of the main advantages. Next one is an adaptability. So these are the important points. We move on to the linked list. Next one is an types. This is important. So we have 4 types of linked list. First one is a singly linked list. So each in this lecture video we focus on the singly linked list only. So each node has a single pointer to the next node. So the navigation is in forward direction only, there is no backward direction. So next one is a doubly linked list. Each node has 2 pointers. They have both previous and also next. We move on to the both side. Next one is a circular linked list. The last node point back to the first node. They form the circle format. So can be a single or doubly linked. Circular doubly linked list is another type. They combine the features of both circular and doubly linked list. So these are the types of linked list. So we will discuss about the singly linked list concept. So what is singly linked list? It is a linked list where each node has 2 parts. One is on data, next one is on pointer. So already says that data which contains the information, pointer which contains the address of the next value. So traversal, so it only traversing in the forward direction only, there is no backward direction. So next, operations. We will discussing about some operations on the simply linked list. First operation is an insertion operation. Second one is a deletion, traversal, and then search. We see one by one in this lecture video. So first one is an insertion. So insertion operations can be done in three ways. First one is we can insert the new node at the beginning of the list, or a new node at the end of the list, or specific location. So there is a three ways to add the new node in the simply linked list. First concept is so we add the node in the beginning of the list. How can we add? We have some procedure. So we have the simply linked list. The elements are A, B, C, D. 4 elements are already present. The first elements also known the head part. The last node, the address part, will containing the null. Null simply says that is the last node. So our query is we want to add the new node at the beginning of the simply linked list. Where I can do that? So first I can do add the new list. Make the first node of the linked list to the new node. So remove the head from the original first node of the linked list. Make the new node as the head of the linked list. We will just simply change the header value. We can easily add at the beginning section. So this is the first way. So next one is inserting at the end of the list. We also say that last node which containing the null value. So now I can add the element at the last part. Go to the last node of the linked list. So previous example, so A, B, C, D, I have the 4 elements. I want to add the element at the last part. Change the next pointer of the last node from null to the new node. We just change the pointer value. So make the next pointer of the new node as null to show the end of the linked list. We simply add the value and add the null as the new node. So null அப்படிங்கிற pointer add in the last node. Next one is an insert at the specific location in the list. We also insert at the any specific location. How I can do that? So traverse the linked list up to the position -1 nodes. We move on to that positions. Once all the position -1 nodes are traversed, allocate memory and the given data into the new node. Point the next pointer of the new node to the next of the current node. Next, point to the next pointer of the current node to the new node. Simply redirect a pointer. We also insert in the middle of the session. So this way we can add the new node in the simply linked list. We say the 3 ways. Next one is the deletion parts. So how can I delete the session? So first I want to delete the node at the beginning of the list. How can I go delete? So to remove the first node of the linked list, to store the current head in the temporary variable name is temp. Move the head pointer to the next node. Delete the temporary node at the finally. So I already say that the first node is also known as the header node. We should remove the first element. We redirect the header pointer to the next element. This way we deleting the elements. So next one is a deletion at the end of the sessions. So how can I can delete? So before you delete the end session, you should check some conditions. Check if the list is empty, it returns the null. So the next one is if the list has only one node. So if the list containing single node, if you delete the single node, it returns the null value also. So again, another case is traverse the list to find the second last node. For example, I have 3 elements. So I move on to the second. So third element should be deleted, second element should contain the null value. So this way we can move on, delete the last element in the simply linked list. So another 2 operations are traverse and then search. Traverse is nothing but to display the elements in the simply list. So already say that it move on to the forward direction one by one. So that way the traversal will move on to from first node to the last node. Search is nothing but it is the process of determining and retrieving the specific node from the front and end of the anywhere in the list. Searching operations will be done. So this way I hope simply linked list is done. So thank you for watching.